Welcome to True Projects. In this video, we are going to explain about a project titled Predicting COVID-19 based on environmental factors with machine learning. So now coming to the introduction part, the integration of machine learning into the realm of COVID-19 research marks a pivotal step towards understanding the relationship between environmental factors and virus transmission. Leveraging the capabilities of these algorithms offers a novel approach to prediction and proactive management of the pandemic. However, challenges such as data quality, model interpretability, and ethical considerations must be navigated to harness the full potential of this technology and safeguarding public health. These factors have the potential to impact the virus transmission dynamics, affecting both the rate of spread and severity of the disease. So now coming to the introduction part of this project is to harness the capabilities of machine learning to unravel the complex relationship between environmental factors and the spread of COVID-19. By doing so, it aims to contribute to the development of data-driven strategies for pandemic management with the potential to shape public health policies and interventions in a more proactive and effective manner. Furthermore, the studies aspire to provide actionable insights to public health agencies, policymakers, and healthcare professionals. By generating reliable predictions, the research aims to empower decision makers with the information necessary to implement targeted interventions and allocate resources more effectively. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE, that is 3.7 version is required. Now coming to the methodology part, first upload COVID-DS4C dataset. In this step, the COVID-DS4C dataset is uploaded and integrated into the analysis framework. The COVID-DS4C dataset is a dataset containing information about COVID-19 cases, patient demographics, clinical data, and more. This dataset serves as a foundation for the subsequent analysis and algorithms applied to predict COVID-19 outcomes based on environmental factors. Second, run Bayes net algorithm. The Bayes net algorithm, also known as Bayesian network, is employed to model probabilistic relationships among variables in the dataset. It uses a directed acyclic graph to represent dependencies between variables, allowing for probabilistic inference. By running the Bayes net algorithm on the dataset, researchers aims to uncover causal relationships and dependencies between environmental factors and COVID-19 outcomes, which can provide insights into the underlying dynamics of the pandemic. Third, pre-processing and feature selection. Before applying any algorithm, data pre-processing is crucial. This involves cleaning the dataset, handling missing values, and preparing the data for analysis. Additionally, feature selection is performed to identify the most relevant variables that contribute to the prediction of COVID-19 outcomes. This step helps improve the efficiency of the subsequent algorithms by focusing on the most informative variables. Fourth, run AD-tree algorithm. The AD-tree algorithm, which stands for Alternating Decision Tree, is utilized to build a predictive model based on the selected features. This algorithm constructs a decision tree by iteratively adding decision nodes and alternating between attributes. Fifth, training performance graph. A training performance graph is a visual representation that illustrates how well the predictive models are learning from the dataset during the training phase. It typically shows how the accuracy or error of the model changes over time or iterations. This graph is essential for assessing the training progress, detecting overfitting or underfitting, and making informed decisions about model tuning. Sixth, run CNN algorithm. The CNN here stands for Convolutional Neural Network algorithm, commonly used in image analysis, is adapted to process the data in the COVID-DS4C dataset. While originally designed for image recognition, CNNs can be applied to sequential data like time series datasets as well. Seventh, run optimize CNN with PSO. Optimizing a CNN with particle swarm optimization, that is PSO, involves fine-tuning the architecture and parameters of the CNN model to improve its performance. PSO is a heuristic optimization technique inspired by the behavior of birds flocking or fish schooling. It helps find optimal or near approach solutions to complex optimization problems. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder which is named as PyCatch. In this we are containing a Python file which is containing the Python script in it. Another folder named as dataset. In this we are containing a dataset in the .csv file. And the folder named as model. In this we are containing some H5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data, performing specific operations. And the custom button and the main are the two Python files which are containing the Python scripts in it. And this is the generated report when we run this .bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. So now here click on upload COVID DS4C dataset button to browse and upload the dataset. Here I am uploading this weather dataset and now click on open button to load the dataset. On this screen you can see dataset loaded and I am displaying some rows from dataset, and in last two lines we can see dataset contains 26,271 records and each record contains 9 columns before applying PCA. So now click on pre-processing features and features selection button to apply PCA algorithm to select important columns and to get the output. Here on this screen we can see after applying PCA we got 7 columns in dataset using 21,016 records for training and 52,055 records for testing. Now dataset features are ready, and now click on run AD tree algorithm button to train AD tree and for getting the output. So here you can see that AD tree, here we got 97% training and testing accuracy, and in confusion matches graph we can see 2905 records are correctly predicted and 80 are wrongly predicted, and this 80 must be reduced to consider as better algorithm. So now closing this graph. Now click on run BaseNight algorithm button to train BaseNight and for getting the output. So here on this screen, BaseNight we got here 90 and 89% as training and testing accuracy, and in confusion matrix graph we can see 2,952 are correctly predicted and 510 are wrongly predicted. So now closing this graph. Click on run CNN algorithm button to train CNN for getting the output. So again here you can see in this graph that CNN we got 98.97% as training accuracy and 98.93 as testing accuracy. In confusion matrix graph we can see 2,947 are correctly predicted and only 8 records are wrongly predicted, and in comparison to all algorithms CNN has got better performance. So now closing this graph. Now click on training performance graph button to get the graph. So now here I have clicked on run optimize CNN with PS. So here we can see similarly we have got the confusion matrix graph for the optimize CNN confusion matrix. So now closing this graph, and now click on training performance graph for calculating the accuracy of all the algorithms. So here in this graph you can see that x-axis represents algorithm names and here y-axis represents accuracy, precision, recall and F1 score, and with different color bar, and in this graph CNN give better accuracy. So now closing this graph, you can see that here we have got the accuracy for all the algorithms over here. So now coming back to the conclusion part, in essence, predicting COVID-19 based on environmental factors with machine learning represents a crucial step towards a more comprehensive comprehension of pandemic dynamics. As the world continues to grapple with the evolving landscape of infectious diseases, this study exemplifies the potential of interdisciplinary collaboration, data-driven methodologies, and technological innovation in fortifying our defenses against global health crises. By harnessing accurate forecasts rooted in environmental data, public health agencies and policymakers can adopt a more proactive stance in resource allocation, intervention planning, and risk assessment. This predictive approach has the potential to bolster the resilience of healthcare systems, minimize the strain on medical facilities, and safeguard vulnerable populations.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.